So, propose two methods for increasing the rate at which salt dissolves in water. You want to increase solubility, always heat, or use smaller crystals. You know, powdered crystals dissolve faster than larger crystals, right? So, heat or use smaller salt crystals. Okay. What is the solubility of potassium nitrate at 20 degrees and at 50 degrees? Okay, potassium nitrate at 20 degrees, it's over here at 30, right? So let's say 30, 30, and what's the unit? Uh, 30, 30 grams per, yeah, just say 30 grams, I guess. And at 50 degrees, we go up, you go over here, it's 80 grams. I think it's 80 grams per, I don't know, okay, it's not just 80 grams. Yeah, 30 grams per 100 grams of water. Yeah, you have to say per 100 grams of water. Per 100 grams of water. Per 100 grams water and per 100 grams water. How much will the solubility of potassium nitrate increase if the temperature increased from 20 to 50? It will increase by 50, صح? So 50 grams per 100 grams water. What mass of potassium nitrate forms if a saturated solution in 100 grams of water is cooled from 40 degrees to 10 degrees and from 60 to 20? Oh, let's start from 40 to 10. Okay, at 40 degrees, how much is it? We're talking about potassium nitrate. At 40 degrees, it's over here at 62, right? Why 62? Because 1, 2, 3, 4, 5 spaces in 10. 10 divided by 5 spaces, so each space is 2, so 62. Okay, so 40 degrees is 62. And at 10 degrees, it's at how much? Here, 20. So 10 degrees, 20. So if you cooled from 40 to 10, how much mass will form? 42 grams. Okay, how about from 60 degrees to 20? 60 degrees, 60 degrees, over here at 102. Okay, so 102 grams per 100 grams water. And 20 degrees, we found it before? Yeah, 20 degrees is 30. So 20 degrees is 30 grams per 100 grams water. So if you cool from 102 to 30, it's 72 grams. Okay, so how much we have? 42 grams and 72 grams. Let me just check this. Ah, 10 degrees. Okay, this is 42. What? At 10 degrees, it was 20? Yeah. 40 degrees, 60. How's it 60? The graph isn't 60 at 40. It's over. Okay, it's because, yeah, okay, they just drew it wrong. Okay, yeah, okay. The 60 is supposed to be a bit up. I think that's what they meant. You know, it's the shaded line over here to be 6. Okay, yeah, that makes sense. Okay, so they'd get 40. Okay, yeah, makes sense. 40 grams. And I'm assuming that over here at 100, oh no, this one's obviously 102. Okay, that one isn't even debatable. Okay, 104. Nice. Um, how? Man, that's not 104. اوكي يا خيي مش فاهم على الجراف وحياة الله مش فاهم. اوكي اذا ال 100 هون. Okay, 100 is here. 102, 104, 106, 108. Okay, yeah, so this is 104. Okay, you just count it properly, I guess. 104. 104 grams per 100 grams water. Okay, so then you subtract it, you'll get 74. Wow, what a hard question. Oh my god. Yes, okay. Not 72, huh? 74. 104 minus 30, 74. What mass of water is needed to dissolve 50 grams of potassium nitrate at 40 degrees Celsius? Type 50 grams of potassium nitrate at 40 degrees. Oh, so let's see what is the solubility at 40 degrees Celsius of potassium nitrate. At 40 degrees Celsius, it's how much? 60. Okay, so at 40 degrees Celsius, what dissolves 60 grams per 100 grams of water? Right? So what are they saying? They're saying, what what mass of water is needed to dissolve 50 grams of potassium nitrate? If it's 60 grams per 100 grams, how much is going to be 50 grams? How much will it need? X, right? So you cross multiply. 60x equals 5,000. You're going to get, ما بعرف. I don't know صراحة. If you divide, yeah, 5,000 divided by 60, you get 83.3. Okay. You do this, you get 83.3. And my phone's getting spammed. I don't know what's happening. But I need to check it. Oh. Okay. I'm back. I think I got 83.3 as the answer. I explained this. What mass of potassium sulfate will dissolve in 2 kilograms of water at 20 degrees Celsius? Same style of question. Potassium sulfate is over here at 20 degrees Celsius. Its solubility is 10. So at 20 degrees Celsius, its solubility is 10 grams per 100 grams water. Okay. They're increasing it to 2,000 grams of water because it's kilograms, right? So we had 10 over 100. It's going to be equal to now how much grams of potassium sulfate in 2000 grams of water? You have to cross multiply and you're going to get 200, I think. Yes, 200. Question 3. Choose the correct answer and complete the following equation. Glucose is what and dissolves in water such as what? Okay, glucose is molecular and dissolves in water. When glucose dissolves in water, it just becomes aqueous. Aqueous. That's it, because it's molecular, right? It's not an electrolyte. Glucose is not an electrolyte. NaCl is ionic, right? And dissolves in water to get Na plus and Cl minus, aqueous and aqueous, okay? HCl gas is molecular, however, it gets you ions because it's an acid, right? So let me check this answer. Yes. Okay. If we mix the following solution, state what will be observed and give the chemical formula of the precipitate, write an ionic equation of the reaction. Okay, BaNO3 and Na2SO4. Okay, barium nitrate with Na2SO4. When you mix barium nitrate with sulfate, what do you get? You get a white precipitate, BaSO4, right? So the net ionic will be Ba plus, or no, Ba2 plus SO4 2 minus to produce BaSO4, which is an insoluble white precipitate. So it's going to be solid. This is aqueous. This is aqueous. Remember? So what will be observed? White precipitate formed. Chemical formula is BaSO4, and this is the net ionic equation. Okay, let's see. To answer this question, list that. No, what's this? No, don't do it like this, man. No. خلاص, you guys know. Barium with sulfate, you get BaSO4. خلاص. Okay, BaSO4 is inside. Okay, whatever. So you get BaSO4. Did they say white precipitate? Yeah, white precipitate will be formed. And this is the net ionic. Okay. AgNO3 and NaCl. Okay, when you add AgNO3 to Cl, what do you get? You get white precipitate, right? That's the observation. What's the chemical formula of it? AgCl. And how do you get AgCl? You got Ag plus aqueous plus Cl minus aqueous to get AgCl. Obviously, solid. BaNO3 and NaCl. Barium and nitrate with chlorine. What do you get here? You should get BaCl. There's no observation, I don't think. Yeah, nothing will be observed. Because look, here you're going to get BaCl2. Okay? Why? Because you have Ba2 plus and Cl minus, right? You crisscross, you're going to get BaCl2 as a precipitate. But it's soluble. It's soluble. We never said anything about it being insoluble. These are the solubility rules, by the way, huh? BaCl2, it needs the solubility rules. What are the solubility rules, guys? Chlorine is always soluble except with Ag, Pb, except with Ag and Pb. Here we don't have Ag, we don't have Pb, so this is going to be soluble. Okay, so will there be any observation? No observation. Okay, but the precipitate formed is this, but it's soluble. Okay, and the net ionic equation will just be Ba2 plus 2Cl minus to produce BaCl2, but it's going to be aqueous because it actually dissolves, right? We didn't say, we never said it's insoluble. Okay, calcium nitrate and Na2CO3, you're going to get calcium carbonate, right? Because always you box up in the middle. NaNO3 we don't care about that. But CaCO3 you're gonna get a precipitate. CaCO3 you should know it's insoluble, I think. Let me see. Yeah, CaCO3 calcium carbonate, Ca2 plus. Yeah, you get CaCO3. This is a white precipitate. So what will be observed? White precipitate formed. The chemical formula is CaCO3, obviously, right? Ca with CO3. Yeah. And the net ionic equation would be Ca2 plus CO3 2 minus to produce CaCO3. You should know CaCO3 does not dissolve, so it's just white. It's just solid, and this is aqueous. Okay, these questions they never come, but like this is just to refresh your knowledge that you can get precipitates when mixing two ionic compounds. Okay, a solution is known to contain PbNO3 and MgNO3. It is required to remove the lead ions from the solution without removing magnesium ions. This can be done by adding just the right amount of what? Here you have PbNO3. Okay, you want to remove the lead. Here's the thing. We need to when we want to remove something, that means we want to get like something that's insoluble, so then we can filter it and remove it to put it on the side. So here, basically, I'm trying to ask you, what do I add here to get me something that's insoluble? Let's see. Obviously not NO3, because NO3 is always soluble, so it's not gonna be this. NaCl, NaCl, we want to remove the lead, so we're removing the Pb2 plus. Okay, so we should look at the negative anion that can react with Pb2 plus to not be soluble. NO3 obviously not, because NO3 is always soluble. H no, ما خلاص H, NH3 no. It's gonna be NaCl. Why? Because you know Cl is always soluble except for two cases, with Ag and Pb. So if you want to remove Pb, you add what to it? Cl, and you do that by adding NaCl. You're gonna get PbCl, which is insoluble, and therefore you removed the Pb. So 5 would be A, because PbCl2 will be formed. It's a precipitate, and then you can filter it out. Easy, because it's gonna be a solid precipitate. It doesn't dissolve. Okay. Solubility rules, I'll pull them up. Let me see one second. These are the solubility rules. Take a look at them if you want. Just a quick refresh. Okay. أنا بدي أخلص والله بس let's see 1 to 5 7 to 12. You skip 6. Okay. Classify the following salts as soluble or slightly soluble. All salts containing NO3. Soluble, right? All salts with alkali metal ions. Alkali metal ions. I think that's group 2 metals. I'm pretty sure soluble, right? Close this. 7. Soluble, yeah. Alkali metal ions are, I think, group 1. This was in the notes. But you memorize it. Group 1 metals will get you soluble. Group 2 metal carbonates. Carbonates are CO3 2 minus. Did we say anything about them being soluble? No, they're slightly soluble. Okay. Chlorides of silver and lead. Chlorides. Okay, chlorides. Cl with Ag and Pb. Are they soluble? No. So we say soluble or slightly soluble, we say slightly. Okay? Because everything always dissolves, but it's just going to be slightly. It's just a شوي منه. Okay? I think carbonate is, I don't think we will. Oh, yeah. CO3 here, remember we said CO3, it's insoluble. Okay? It's insoluble except with the big 5. CO3 and OH, they're insoluble except with the big 5. Okay? طيب. So, when did I say group 1? Lena Krebs. Oh yeah, group 1 metals in NaK, but you're always gonna see NaK. You don't really see Li. You don't see lithium. Okay. Given 4 separate test tubes with A, B, C, and D, containing solutions of 4 different potassium halides, a few millimeters was added. Okay, yellow precipitate, white precipitate, cream precipitate, no change. Okay. Halides, what are they? F, Cl, Br, I. Okay, minus. Okay. Yellow precipitate, iodine. White precipitate, Cl minus. Cream precipitate, Br minus. No change. What's going to be? F minus. Okay. Give the chemical formula for the halide present in each of the following. I think it's going to be like, well, is it as a compound? Potassium halides. Okay. Potassium halide. Okay, yeah. So, okay, it's going to be Ki, KCl, and KBr, and KF. Very easy. Okay. Yeah. Fill in the table to identify the ion present after a flame test. Yellow flame test, Na+, right? Lilac flame test, K+. Crimson red, Li+. Blue green, that's going to be copper, Cu+, Cu2+. Pale green is Ba2+. Brick red is Ca2+. Let's check. Sodium, potassium, lithium, copper, barium, calcium. Yes. And I wrote them like this. That's completely fine if you write it like this, by the way. And I usually, what I do in exams, to make sure I'm on the safe side, I say Na+ and I say sodium ion. I always write it in brackets. Okay, just to make sure I get the mark. Because you never know. ما بتعرف someday you're gonna get a corrector ما له خلق على حاله and he just wants to remove marks for you, which is completely normal. We don't have much left. We can get this done in 10 minutes. Okay, 7 different solutions. CR. Okay, so we have to choose reddish brown precipitate with sodium hydroxide. Reddish brown, Fe3 plus. Yeah, this is the table of reactions, huh? And I'm not just ما عم بألف. They're all here, okay, in the notes drive, okay. Dirty green precipitate does not dissolve in excess base, so Fe2 plus. Okay, blue precipitate, Cu2 plus, without even reading. White precipitate with sodium hydroxide, no precipitate with ammonia. So, no reaction with ammonia, what is it? Ca2 plus, no reaction, okay? No reaction with ammonia, Ca2 plus, that's the only one. Remember calzone, calzone. And then we had NaOH and NH3. Here we had insoluble with excess NaOH, no reaction with ammonia. Here we had soluble, insoluble, and then soluble, soluble. Okay, so it white precipitate with sodium hydroxide does not form anything with ammonia, so NH3. Okay, don't mix up does not form precipitate and does not dissolve. They're two different things. Okay, white precipitate with ammonia does not dissolve in excess ammonia. See, this is different than this. So which one does not dissolve in excess ammonia? Al 3 plus. Okay, let me put the charges here because some people they just put Al. Guys, where all these tests with the charges all these tests you need to put the ion with their charge. White precipitate with sodium hydroxide that redissolves in excess ammonia. The only one that dissolves in excess ammonia is 2 plus Cn. Green precipitate with sodium hydroxide and it is soluble in excess sodium hydroxide. That's chromium 3 plus. Aslan, I'm getting these from the choices here, huh? I'm sure of these. Let me see. Yes. Okay, good. 11. Given the following ions, which of the given okay, this comes in the exam, which of the ions forms a white precipitate upon addition of SO4? Okay, white precipitate of K after you add K2SO4. SO4, and what gets you white precipitate? It should be, I think it's barium, right? Because BaSO4. Yeah, Ba. You got Ba and also calcium. I wrote it in my notes. It was over here. Yeah. So SO4 2 minus, okay. You can either add Ba2 plus and Ca. Okay, I don't know why I didn't write the Ca. And I didn't write the plus. I don't think I was drunk in class. But I should have written Ca2 plus and Ba2 plus. Okay, because you could get CaCO3, CaSO4, and CaSO3. Okay, you can substitute Ba2 plus for barium. So let me go back to the question. To get a white precipitate with SO4, it needs to be Ca2 plus or Ba2 plus. Okay, طيب. Forms a white precipitate with NaCl. White precipitate with Cl, what do you add? Ag plus, because AgCl gets you a white precipitate. Which of the ions forms a creamy precipitate? KBr. Again, creamy with Br, what is it? Always with silver. AgBr. So what ion do you add? Ag plus. Given the following ions, which of the following releases a gas that turns lime water milky? Lime water milky means CO2 gas. Which gets you CO2 gas? CO3 2 minus. Which one releases pungent smell gas? Pungent smell gas, NH3. Okay. Here's how you know. How do you know if it's NH4 or NO3? Because they both released ammonia. Did they say anything about aluminium? No. If it doesn't need aluminium, then NH4 plus. But now here, when they say aluminium, it's going to be NO3 minus. Because these both get you ammonia. They both get you NH3. Okay. Okay, which of the given ions releases a gas with choking odor? Choking odor is SO2 gas. This came in the periodic. People were like, whoa, what? Okay, so basically, they gave you potassium manganate, and they were like, guys, the potassium manganate didn't change color. What does that mean? People put no SO2 gas present. That's correct. Okay, but what does that mean? Okay, it's no SO2 gas present. But what does that mean for the test? Okay, no SO2 gas present. You're supposed to say, okay, what gets you SO2 gas, guys? SO3 2 minus, because SO3 2 minus is when reacting with an acid. Okay, it gets you SO2 gas and SO2 gas and water, I think. But anyway, that's not the point. You are supposed to say no SO3 2 minus. You're supposed to say this in your periodic written. People put no SO2 gas. طب why? Okay, that makes sense. But you're supposed to. We're talking about the test. شو خص SO2? Do you ever test for SO2? We don't test for SO2. There's no test, right? There's the test for SO3 2 minus. Then you're supposed to say, and what I wrote personally, I said no SO2 gas is present, which means that there was no SO3 2 minus in the solution. Question 12 قصدي لا 12 done. 16 هلا last question. Many insoluble salts can be prepared by precipitation reaction between salts. All potassium salts and all nitrate salts are soluble. A student adds potassium sulfate to a barium nitrate solution and the white precipitate is formed. When you get the white precipitate from sulfate and barium, what's that precipitate? You guys know it's BaSO4. Very easy. Write the chemical equation for the reaction between potassium sulfate and barium nitrate. They said chemical equation, so you have to say the whole thing. So K2SO4 aqueous plus BaNO3, which is also aqueous. Okay, this is BaNO3 too. To produce, we said BaSO4, right? BaSO4, which is a solid. And what are you left with? KNO3, potassium nitrate. And I think you should balance this, so it should be 2KNO3. I think that's balanced. The rest is balanced. This is obviously going to be aqueous. Okay, let's check this answer. Go to 16. Okay. Yeah, okay. I put a 2 here because it was 2 NO3s here, so I need to put a 2 here. Another student adds potassium sulfate K2CO3 to a solution of silver nitrate AgNO3. A white precipitate is also formed. What is the chemical formula of the white precipitate? We were never taught this one, but apparently, also when you add Ag to CO3, you get a white precipitate. AgCO3. Okay, AgCO3 is a white precipitate. Okay, I never knew this, but now we know it. So if it comes in exam, you can't say, oh, we were never taught this. They'll tell you, it was in the course version. Okay, AgCO3, right? A net ionic between potassium carbon. Okay, what net ionic? We got AgCO3. So Ag plus, aqueous plus CO3, 2 minus. Is AgCO3? You have to crisscross. Wait, it's not AgCO3. Ag plus, CO3, 2 minus. If you crisscross, it's Ag2CO3. Take the 2 here, huh? Ag2CO3. CO3, 2 minus to get Ag2, which is aqueous, huh? To get Ag2CO3. Okay, and this is going to be a solid, obviously, because it's a precipitate. And you have two Ags, so you have to put 2 here. Barium nitrate solution produces a white precipitate with both carbonate ions and sulfate ions. Why acidified barium nitrate solution is used to distinguish between carbonate ions and sulfate ions? I think because one dissolves and the other one doesn't dissolve in acid, something like this. Huh? Oh shit. Okay, yeah, makes sense. Why do you use acidified barium between carbonate and sulfate? You guys know when you add an acid to carbonate, you get CO2 gas. But when you add an acid to sulfate, nothing happens. Remember, I'm saying sulfate, not sulfite. Sulfate is SO4. Sulfite is SO3, 2 minus. Okay. Because an acid, when reacted with carbonate, will get you CO2. So why do we use acidified barium nitrate? Because since it's acidified, you can know if it's a carbonate or sulfate, because they both get you white precipitate. How do I know which one's which, yahi? When you add an acid to carbonate, it's gonna get you carbon dioxide gas. When you add an acid to sulfate, nothing's gonna happen. So here you're just gonna get white precipitate, but here you're gonna get white precipitate and carbon dioxide gas. Okay, so you're supposed to say it reacts with carbonate to produce CO2 gas. Okay, that's it. Thank you so much for watching and good luck.